Now we want to evaluate the integral of sine of 2 minus x raised to the power of 5, cosine of 2 minus x raised to the power of 4 dx. So our focus here is the odd exponent of sine of 2 minus x. So we have an odd exponent here, and we have an even exponent here. So regardless of the exponent na odd, na even rather here, our focus is here on the odd exponent. So if we see this case, what we want to do here is to factor out 1, so that sine of 2 minus x, so that we subtract 1 from the exponent 5. So we will now rewrite this as the integral of sine to the power of 4 of 2 minus x. Simply copy cosine to the power of 4 of 2 minus x, and then just factor out sine of 2 minus x dx. So we isolated this factor here, but take note that we are not changing the given. If we multiply sine of 2 minus x to sine of 2 minus x raised to the power of 4, we still get sine of 2 minus x raised to the power of 5. So what we want to do here, we isolated this factor here because we want this to be our du later on. So if this is our du, then our u should be in terms of cosine. So we have to express everything here in terms of cosine. So this is already cosine, but we still have sine of 2 minus x raised to the power of 4. We still cannot use the Pythagorean identity for this one because the exponent of 4 is 4, and in Pythagorean identity, the exponent is 2. So we are going to express the power of 4 now as a power of 2. Recall our laws of exponents. Recall that a raised to the power of m, quantity raised to the power of n, is equal to a raised to the power of m times n. So that if we have raised to the power of, let's say, 4, that's just equal to a raised to the power of 2 raised to the power of 2, right? So what we'll do here is just multiply the powers. So that's what we're going to do here in sine of 2 minus x raised to the power of 4. So we can rewrite that as the integral of sine squared of 2 minus x quantity raised to the power of 2. So that's 2 times 2, that would give us 4. And simply copy the other parts of the integrand, that's cosine to the power of 4 of 2 minus x sine of 2 minus x dx. So now that the exponent of sine of 2 minus x is already 2, then we can use the Pythagorean identity. Remember, it's sine squared u plus cosine squared u equals 1. And if you want to express sine in terms of cosine, then sine squared u equals 1 minus cosine squared u. So rewriting, we now have, this is now 1 minus cosine squared of 2 minus x, quantity raised to the power of 2, cosine to the power of 4 of 2 minus x, sine of 2 minus x dx. So now that everything here has been expressed in terms of cosine, and we can now perform substitution by letting u equals cosine 2 minus x. So that du equals negative sine of 2 minus x. Remember, the differential of cosine is negative sine. And we still have to find the differential of 2 minus x, which is negative 1. So we just write negative dx. So negative and negative would give us positive. Therefore, du is just equal to sine of 2 minus x dx, which means that this is just equal to du. So changing everything now in terms of changing, diba? Our variable here is x. So we'll now change everything here in terms of u. So that would be 1 minus cosine of 2 minus x is u, and this is raised to the power of 2. So that's u squared raised to the power of 2, u to the power of 4 du. Now, before we can distribute u to the power of 4 here, we still have to expand the binomial here, this raised to the power of 2. Remember how to expand a binomial? That's 1 minus 2u squared plus u to the power of 4, u to the power of 4 du. So we can now distribute u to the power of 4 before integrating. And we are going to arrange in decreasing order. So we're going to start here. So u to the power of 4 times u to the power of 4. That's u to the power of 8 minus, that's u to the power of 4 times 2u raised to the power of 2. That would be 2u raised to the power of 6 plus u to the power of 4 times 1. That is equal to u to the power of 4 and then du. So we can now integrate. That would give us u to the power of 9 over 9 minus 2u raised to the power of 7 over 7 plus u to the power of 5 over 5 plus c. And then we have to rewrite back to the original function. Our u is cosine of 2 minus x, so we have to rewrite it in terms of cosine. Okay, so cosine of 2 minus x raised to the power of 9 over 9 minus 2 cosine of 2 minus x raised to the power of 7 over 7 plus cosine of 2 minus x raised to the power of 5 over 5 plus c.